All right, what do you do first? Factor. Kind of in general, anytime I ask anything for the next 2 months, what is the first thing you do? Factor, right? Right? You have to do that first, right? Well, what can I factor? I look at the only thing in here I can factor is that x squared minus 1. All right, that's fine. All right, so when I rewrite this, then I get 1 plus 1 over x plus 1, x minus 1, all over 1 plus 1 over x minus 1. And you're thinking, how does that help us, right? I just made it worse, right? We went from this big to this big, right? Now, you don't like fractions, right? That's going to be a common theme for the rest of this chapter, right? You don't like fractions, and what makes a fraction is the denominator. So, what do I need to multiply by to get rid of the denominator? What do I need to do? What needs to go here so that I don't have a fraction up here? Yeah. What do I multiply here that's going to get rid of this denominator? X plus 1, x minus 1. Right? So I'm going to do x plus 1, x minus 1. Of course, whatever you do to the top, you have to do to the bottom. That's going to give us x plus 1 times x minus 1. Now, let's see what happens. Are we okay that this times this, everything cancels out, we're just left with a 1? Okay. Are we okay that this times this is going to give me that x plus 1 times x minus 1? Is everybody okay with that step? All right. Next up, when I multiply, what's left? So imagine this gets distributed like there's an x plus 1, x minus 1. And this is an x plus 1 times x minus 1. All right. What's left? So what's going to be left here? Okay, the x minus 1's cancel. And so what's going to be left here is an x plus 1. Of course, what's left here is the x plus 1 times x minus 1. Ready? Let me make that a little more legible. I get x plus 1, x minus plus 1, right? Now, I think this looks nicer than this. Right? If we look at what we did, well, okay, what we factored, and then we decided, okay, what do we have to get rid? We have to get rid of our denominator, right? Let's get rid of as many fractions as we can. So multiply top and bottom. Now you have to do something that I told you that you don't have to do 90% of the time. And most of the time when things are factored, you leave them factored. But this is one of the cases where we've got to clean up. Like when I look at this thing, well, you have to multiply this out. So what's x plus 1 times x minus 1? Creates our difference of squares. So that's going to give me x squared minus 1, and then I have that plus 1. Okay, that's the top. This gives me this, and then plus 1. Now this part, I multiply it and I end up with, this is x squared minus 1, and then I get plus x plus 1. Now things get a little interesting. See, what's the top become? You got x squared minus 1 plus 1, what's going to happen? Just get an x squared. And what happens on the bottom? Right? The minus 1 and the plus 1 cancel. And so I get x squared plus x. Oh, we're not done. See, the reason we're not done is, if I had just given you this problem at the very beginning, could we factor the bottom? What's in common in the bottom?
X.
At x. And so this becomes x squared over x times x plus 1. And now what happens? That x cancels one of those x's, doesn't it? And so when this x cancels one of those x's, our final answer, I'm going to put it up here so I... That's a heck of a lot simpler than this, isn't it? When you started this problem, I don't think you would have thought it would have gotten down, because that's pretty small. I mean, that's significantly simpler than what we started with. And I like this in that, I mean, it kind of, like all of the ideas I talked about yesterday, parts of them are included in all of this. Okay. So what happened, just kind of recap, we factored. We got rid of the denominator. Right? And then, once we looked at this, we said, all right, now I've got to, clean up the top, clean up the bottom, which in this case meant multiply things out. And then I get here, and I'm not quite done, because I can still factor. I can still simplify some more. Yes?
Is it okay if I got the same answer, but I didn't factor at the start, and I found the least common denominator and changed it into a multiplication thing?
Oh yeah, you can do it that way. There's nothing wrong with that. I have a feeling you probably did more steps. I mean, I think I effectively did 1 step, 2, and 3 or 4, but those are smaller. All right, so homework. I asked in my first period class, and any questions on homework, and for first, as far as 8.1 goes, did anybody have any issues with 8.1? Chord. All right. What do you do first? Thank you, right? I said, what do you do first every time? We factor, right? So what do we do first? We factor, all right? Well, when I look at this, it's like I can't do a whole lot with the top, so I'm just going to write that as r plus 6 over r minus 1 over r plus 2. But when I look at this, I can factor. Okay? Like this thing, that factors. That's going to factor as r plus 1 times r plus 3. And what's the bottom factor as?
R
out.
Here, pull the r out. So we get r times r plus 2. Everybody okay with our first step? Okay. Factor. Now we had more to factor this time, but than the warm up, but same thing. All right, next up. You don't like fractions, right? So you think, how do I get rid of the fractions up top? How do I get rid of the fractions on the bottom? What do I need to multiply by? Here, we'll do it this way. What do I need to multiply by here so I get rid of the fraction in the bottom? R times r plus 2, right? Everybody okay with that? So I'm going to do r times r plus 2. Of course, whatever you do at the bottom, you have to do the top. So that's r times r plus 2. Well, let's see. Let's deal with the bottom. What's going to be here now?
1.
Well, this canceled, right? This thing, right? Everybody okay that's going to be the only thing in the bottom? So that gives me r plus 1 times r plus 3. Now, the way you deal with this is imagine that gets distributed to each of those terms. So imagine there's like an r plus 2 here. There's an r and an r plus 2 here, right? And like this r cancels this r. Right? And this r plus 2 cancels this r plus 2. So what's left here? What's left in this first spot?
R plus 2, R plus 6 minus R.
Right. Everybody see that if this cancels, I'm left with an R plus 6 and an R plus 2? Can y'all see that? Because this R canceled this R out. So I'm left with R plus 6 and an R plus 2.
Minus
We get R plus 6 and an R plus 2. And then minus an R, right? Everybody see how we got here? Okay, now, nothing to do in the bottom. How do you know when you leave things factored, you're not adding or subtracting anything to them? We want to leave this factored. The problem is, this is multiplied, but there's this minus R, so we're going to have to work this out. And so when we work this out, let's see, it's going to give me R squared plus 8R plus 12 minus R all over R plus 1 times R plus 3. Huh. Well, I guess I can clean that up a little bit, right? Because that 8R minus R, right? And I'm running out of room. I wrote way too big. So I end up with, sorry, I've got to come back over here. So I end up with R squared plus 7R plus 12 all over R plus 1 times R plus 3. And, I don't know, about 80–90% of the time, you're done. All right? But this is not the 80 or 90%. This is the 10 or 20%. And when you look at this top, anytime you see like variable squared, variable, and number, what always has to come into your mind, you have to think, can I factor that? Well, can I factor R squared plus 7R plus 12?
Yes.
Yeah. That's going to factor as R plus 3 times R plus 4. And that's all over R plus 1 times R plus 3. Oh, look, what happens? The R plus 3's cancel. And what started off as this ugly thing simplifies to R plus 4 over R plus 1. Did that make sense? This is. Yeah. Does that make sense? Yeah, I like this one. Right? Everything that's done in this problem is exactly what we've talked about. It's like the problem just keeps going, right? You do one thing, oh, I can do it. That gives me a chance to do another. That gives me a chance to do another. And even at the end, it factors. Just from a person who tries to write questions, it's a pain to create something. After you do all of these steps, you actually end up with something that can factor here. It's hard to create that. So I have some appreciation for the person who created the problem. That's not easy. When I've tried to do it, it takes me a long time to make sure you get something you can factor at the end. All right. So everybody okay with this? All right. So today we are going to talk about solving equations. And actually, before we start talking about solving rational equations, let's refresh your memory. Let's do x squared minus x minus 6 equals 0. So everybody solve that one. Hopefully this is an easy one to solve, right? It factors nicely, right? You look at it, okay, that's x minus 3, x plus 2 equals 0, okay, x equals 3 and negative 2. Everybody okay with that? Just refreshing our memory how to solve. So, how do you solve a rational equation? A rational equation means you got stuff with fractions in it. So what if I give you x minus 1 is equal to 6 over x? What? Yeah, you don't like fractions, right? Remember that theme, we don't like fractions? And so when I look at see that 6 over x, it's like I want to get rid of the fraction. So to get rid of the fraction, I have to multiply by x. Now, the thing you've got to remember is you got to multiply everything by x. So you multiply this by x, you got to multiply this by x, and you got to multiply this by x. And when you do that, what do we get? X squared minus x is equal to 6, right? Guess how you solve that?
Is it equal to 6x?
Well, no, the x canceled, right?
Oh, sorry,
Yeah.
it's not.
Do you move it to the left side?
Wait, Mr. Alves?
To 0? Make it
Yeah.
equal to 0?
Yeah, you said it equals 0. Yes.
Wouldn't it be positive 2, negative 3?
So you flip the sums, you flip them.
What makes this 0?
Oh, okay, never mind.
Okay. And so now, anytime you see x squared and x in a number, you set it equal to 0 and hope you factor, so that gives x squared minus x minus 6 equals 0. And we already know how to solve that, don't we? I think it's kind of interesting that these are effectively the same problem, aren't they? But they kind of look different. At least they start off that way. All right. What if,
Sorry, just to finish the problem, it's x is equal to 6, right?
well, when we finish this, you're going to factor.
Oh, you factor it and
Yeah,
then.
so you get x minus 3, x plus 2 is equal to 0. So x is equal to 3 and negative 2.
Oh, okay.
Same thing as the other problem. All right, well, what if I give you 5 over 2x minus 2 is equal to 15 over x squared minus 1? All right, what are we going to do first?
Factor.
Thank you. See, y'all are learning, right? What do you do first? Factor, right? You look at things and you ask, well, is there anything you can factor? Well, yeah. When I look at this, I get 5 over, well, I can factor a 2 out, so that's 2, and that gives me an x minus 1. That's going to give me 15 over, well, that's an x plus 1, and an x minus 1. Everybody okay with that? And you know what? I still don't like fractions. Since I don't like fractions, I have to think, well, what gets rid of the fraction here?
X plus 1, X minus 1.
X plus 1, x minus 1. Of course, whatever you do one side, you have to do the other. Well, I need to get rid of the fractions here too, don't I? So what do I need to multiply? What do I need to do to get rid of the fractions over here? The denominators over here?
You can take the X minus 1 out.
I think I just need a 2, don't I? Because the x minus 1's already going to get canceled, isn't it? So I put a 2 on this side. Of course, whatever to this side, I got to do to that side. And now, let's see, this cancels this, and this cancels this. And so I'm left with 5 times x plus 1. And let's see, this cancels this cancels this. I'm left with 30. And that equation's pretty easy to solve, isn't it? I mean, you could distribute the 5 and solve, but I kind of like, I'm going to divide both sides by 5, so that gives me x plus 1 is equal to 6. And so I end up with x is equal to 5. Okay, does this kind of make sense? And all this is hinging on the fact of we don't like fractions. Okay. So what if I give you 1 over x minus 3 plus 1 over x plus 5. I need to erase this. I want to make sure I have enough room to write. I don't want to run to the edge of the wall. So. I'll give you a few seconds to write that down. All right, everybody got it written down? Not yet? Or you just don't want to do it? I'm giving you. Yeah. Kind of looks ugly, doesn't it? I agree. I think that looks hideous. Right? Okay. And the main reason it looks hideous is it's got fractions all over it, right? But we don't like fractions. And since we don't like fractions, I want to get rid of denominators. What do I need to do to get rid of this denominator? Multiply everything by x minus, you can't just multiply one thing by x minus 3. You've got to multiply everything by x minus 3. So I'm going to put an x minus 3 here, an x minus 3 here, and an x minus 3 here. Everybody okay with that? Does that get rid of all my denominators? Well, no, does it? What else do I need to get rid of? What else do I need to multiply by? I need to multiply by an x plus 5. All right, so I get an x plus 5, I get an x plus 5, and I get an x plus 5. Everybody okay with that? Now, I completely agree this is ugly. Okay? This step is ugly, but the next step looks nice. So now let's talk about what's left. Well, the x minus 3 cancel the x minus 3. What's left here? X plus 5. All right, x plus 5 cancel. What's left here? Let's say the x minus 3 and the x minus 3 cancel. What's left here? X plus 1 times x plus 5. Oh, to me, this looks much nicer than this. Right? Like the original problem, what I had in black, looks kind of miserable, right? And after one ugly step, it doesn't look so bad because we don't have any fractions. You still have to solve it. So what do we need to do? I guess I can combine these, right? If I combine this, that's going to give me a 2x plus 2. And I multiply that out. Let's see. It gives me x squared plus 6x plus 5. Now, how do I solve this? Well, set equal to 0 in factor. Right? Anytime you see x squared and x in number, right? The only way you solve this is you set it equal to 0 in factor. So I'll move these over. And when I move those over, that gives me 0 is equal to x squared. I subtract 2x from both sides. 4x plus 3. And, oh, well, that's nice. This will factor as x plus 3, x plus 1. And so what are my answers?
Negative 3, negative 1.
Yeah, x equals negative 3 and negative 1. All right, let's make sure we understand the kind of what happened. First thing we did was, well, there's nothing to factor, so we couldn't. Then we got rid of our denominators. So this thing that was kind of intimidating after we got rid of the denominators, after I got rid of all the fractions, not as intimidating. Now, this is effectively something you could have been assigned in Algebra 1. Multiply those out. Okay, set equals 0 in factor, and so end up with negative 3 and negative 1. This kind of makes sense. Right? So, like, your goal in solving things with fractions is get rid of the fractions. so what if, let's see. Oh, wait, I'm going to need to erase this because I need more room. Sorry. Now, if I give you 4 over give everybody a chance to write that down. Okay. Everybody got it down? What do you think the first thing I'm going to do is? Good job, right? Remembering factor. So let's see, we factor this, and so it's going to give me 4 over x minus 3, x plus 1 equals x over x minus 3 minus 1 over x plus 1. Here's a secret. Every time you do these problems, if you see a quadratic and you see like an x minus 3 and an x plus 1, 99% of the time, this is the factors of this. Like they actually tell you how to factor it over here. All right, so we're looking at this. Now what? Get rid of the denominators. All right, how am I going to get rid of, what do I multiply everything by? Perfect. So I'm going to multiply everything by an x minus 3, x plus 1, x minus 3, x plus 1, x minus 3, x plus 1, right? So kind of an ugly step, but the next part doesn't look so bad. All right, when everything cancels, what's left here? A 4. What's left here? Okay, we get x times x plus 1. And what's left here? Is everybody okay with that? That doesn't look too bad, does it? It looks a heck of a lot better than this, doesn't it? All right, so what we're doing is we're trying to make this look nice. Well, you know, so now it's not so bad to solve. Let's see, I get 4 equals, what's that, x squared plus x minus x plus 3, right? Got to remember to distribute the minus sign. And, well, that's interesting. So 4 is equal to x squared plus 3, x squared is equal to 1, and x is equal to plus or minus 1. Everybody okay with that? So we solved and we got our answers. So what are our answers? 1 and negative. Well, the problem is they're not. Like we did this whole thing, and we found out that x equals plus and negative, x equals plus 1 or minus 1, but it's not. So why? Well, you remember on Monday I talked about excluded values? Like excluded values, whenever the bottom equals 0, that's a problem. When we look at the original problem, what are my excluded values? What can x not be? 3 and negative 1. Everybody see that? Remember that we did at the beginning? We have excluded values. So our excluded values were x can't equal 3 and x can't equal negative. Oh, well, wait a minute. If x can't equal negative 1, can my answers be plus or minus 1? What's our answer? Just 1. So when you wrote down x equals plus 1 and x equals negative 1, that negative 1 wasn't legal, right? So then the question should be, well, how on earth did I get a plus and minus 1 here when it wasn't even supposed to be in the problem, right? How did we end up with a plus 1 and a negative 1 when we started with this problem? And the answer is we changed the problem. We changed the question. See, the original question has fractions, right? At any time you have fractions, you have restrictions, like x can't be, in this case, negative 1 and 3. When we got rid of the fractions, this green question is similar to the black question, but it's different because this has no restrictions. This question is a lot easier to solve, though. So what we did is we solved the easy equation, and then what we have to do is we have to check to make sure that our answers are legal. Okay? So how do you do that? It's actually pretty easy. You just make sure you're not dividing by 0. You don't have to go through at the beginning and say I have excluded values, 3 and negative 1. No, nobody does that. What you do is you solve the problem, and when you get to the end, you go, oh, wait, I got to check my answers. Negative 1 doesn't work. It's called an extraneous answer. And you may think, well, did we have extraneous answers in the previous problems? No. I purposely did not give you any extraneous answers because it's the first few examples. So here is, actually,